And you also mentioned demineralization. Okay, so I think most of our audience would be familiar with the concept of RO, reverse osmosis. So we pressurize water, then depending on the pressure, the salts actually get distributed. So typical RO limits will be up between 10 to say 50 ppm. My understanding of it basically. But the ultra pure water that you're talking about utilizes a process called demineralization, where it is ppb to ppt in terms of that. So can you explain the demineralization process in relation to RO, for example?
So what we do generally, I will talk about a general any plant, power plant. So water source is same. Where you take a drinking water, same source you take a water from a river, or if it's countries like Saudi Arabia where they have desal plant, and then end of the day you get a water. So there are a lot of pre-treatments are done with this water, which include settlements of any suspended impurities in settlement tanks, then filtration, ultrafiltration. After that, it's assumed that there is no any suspended impurities, but still there are a lot of dissolved impurities. So dissolved impurities means different kind of salts, inorganic salts dissolved in a particular water. As you know, water is very good solvent. We studied in school. So it dissolves almost all impurities around it. So it includes calcium salts, magnesium salt, potassium salts, sodium salts. These are all dissolved in this water. Now, this water, if you are using for a cooling water as a room temperature with some corrosion inhibitors and some anti-scalants, you can use as a cooling water in normal circuits, like cooling water circuits in your air conditioning, etc. But when it comes to boiler or steam generation, you are going to convert this water into steam. So as you convert water into steam, solubility of water falls like anything. And that time it will start throwing out all these dissolved impurities. And that's why demineralization becomes essential, particularly for high pressure water tube boilers. Because water is flowing through tubes, and any scaling or deposition will actually get deposited within tubes, which are afterwards very difficult to clean. You need to go for chemical cleaning or very tedious processes. And for that you need to stop your plant, obviously.
Which is the bigger problem.
Which is a bigger problem. So to avoid that, a demineralization process is introduced. So very small portion of this pre-treated water actually goes to boiler. And that's why this demineralized water becomes a costly utility. And that's why you want to recycle it in a condenser and put it back in a Rankine cycle. So this demineralized water in DM plant, there are different technologies. So most common is a use of resins. So we actually pull out salts, anions and cations by this process called demineralization using resins. Okay. Now people are also talking about EDI technologies where electricity is used to demineralize it. Okay. And now people are talking about hydrogen. So they, as further you need to demineralize it because electrolyzers